welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. All right, hi everyone. Welcome to House of ZK's Bitcoin series special with Sims, who is CEO of Alpen Labs. Thank you so much, Sims, for being here today. I'm very excited to dive into the vision behind Alpen's design rationale, including Glock, the need for programmability in Bitcoin, and also some use cases that Alpen can enable. So thank you so much.
Great. Thanks. Thanks, Alice, for having me.
Yeah, of course. I'm wondering if we can first start off with an introduction of yourself. When I was looking into you and preparing for this episode, I saw that you had quite a few different diverse experiences. So I wanted to also ask you, like, what led you to transition from more of an AI focus? I know that you were doing some academic related research back when you were in university, and then you also co-founded Synapse as well, and then was involved with Palantir for some time. So curious to hear about what led you to transition from that AI focus to more towards Bitcoin and ZK.
Yeah. I'll start with maybe uh, even before AI. Actually, I was a absolute like math nerd. I got into math really early. And yeah, absolute math build all the way kind of middle school, high school days. I actually found out about Bitcoin pretty early. There's a website called Stumble Upon, which no longer around, one of my favorite websites on the internet. So I actually quite literally stumbled upon the Bitcoin white paper. So there's like a button you click on Stumble Upon, and it would take you to a random esoteric part of the web, sort of based on your interests. And I think it was in I was kind of late high school at that point, 2011. And I found it really interesting. I actually read and reread the white paper quite a bit. Um, and I couldn't convince myself that like it felt like something that like someone should be able to break this, and then of course add in some youthful exuberance. I should be able to break this. So that was my first foray really into Bitcoin, which was joining the IRC channels, the chats, and like really figuring out different kinds of attacks on Bitcoin. I still have this like super long kind of science fair type white paper around Bitcoin and kind of the vulnerabilities that I saw at that point. So that was kind of really the first foray into Bitcoin. Maybe a decade following that, I was really passive in the space. I didn't, not actively building anything, doing anything. Occasionally during the block size wars, I remember kind of I was in Boston at the time attending some conferences and meetups in Fidelity or other kind of areas. But that was kind of the initial foray. I got into AI at MIT. So this is like 2013. As an undergrad, started taking basically a bunch of like more theoretical track math courses. Uh, and then around that same time, there were like some really interesting things happening within AI, more in the academic sense. So like AlexNet, there's like a seminal paper that came out in 2012, I think. And like neural nets were sort of becoming a thing like that, that might work. And so uh, as an undergrad, it was sort of really cutting edge, and a lot of grad students still were not working on that yet. So I got an opportunity to work on a bunch of things around that. And AI was like quite interesting in that lens because it was not just like on the academic side. It was kind of an interesting time to really think deeply about kind of different approaches, different kinds of you know more algorithmic kind of level things. Although there's definitely dark science or dark art to that as well as a science. But it also allowed me to like rapidly prototype things and just put it in front of someone and see how they use it. And I thought that was just like it's such a cool process to be able to like kind of obsess over that, you know, exact kind of user experience and realize that's something I really enjoyed. So went really deep into that. And so Synapse, you mentioned, was sort of it was my first company. Was right out of college. I had two other co-founders that knew, everything that I definitely did not had, like even the business side, the operations side, the fundraising side, et cetera, covered. And I was really there with the expertise in product and tech, especially within AI. And so that was a foray kind of within, yeah, it was like a natural transition for me, I suppose. And we were in the Bay Area, built a company up for 4 years to, kind of really 0 to 1 kind of building experience was just one of the most phenomenal, experiences for me personally in terms of growth. Uh, and realized so much of this was not just around the technology. It's again around like how people use it. Are we actually building for the kind of pursuing product market fit in this way? It was about kind of the culture of the organization internally. All of these areas that I found really just fascinating. And so we ended up selling that company to Palantir in 2020, and so that's how I transitioned over to Palantir. Spent 2 years there as lead of the Edge AI team. And, I was already itching to kind of go back and work on like something really ambitious with a, smaller team. The intensity of kind of the startup experience was awesome. I didn't really have a clear idea of exactly wanting to work on Bitcoin or crypto at the time. But, I definitely wanted to work on something that could take a very long time. But, if we're successful, the impact should be well beyond markets that can already, are already well off and can kind of purchase those products. A lot of typical, SaaS or like software industry is around building products that, you just then go and sell into markets that are already kind of well off and could kind of afford this tech. But there was something like really, I was really drawn, I think, to Bitcoin, and I was really drawn to like kind of blockchain tech as a way to one, whatever we end up building, the footprint is really anyone that has the internet, with the kind of uncensorable uh, properties and permissionless properties that these technologies have, and I was also drawn specifically because I felt like there were, 2021, 2022, there's so much noise and like it's so fascinating following this. It was like there's like a real industry out of like this tiny thing that I remember seeing back in the day. It was just like, on Bitcoin forums and like IRCs and so on. Now there's like a real kind of industry, and yet I felt like that there were so many kind of so much of the early vision was still not fulfilled at that point. And we were definitely seeing this explosion, but there's so much noise amongst you know uh, the signal in that. And so uh, personally, for me, the trigger kind of moment was, I'm originally from Nepal. I was born there. I have a lot of relatives. Most of my family is back in Nepal. And uh, there's like I was basically my cousin was going through college at the time, and I was supporting him, and so like sending some like remittances basically back. And even in 2021, it was like such a painful experience. It was I remember there's like a 10-day kind of period just to get like some money there, and it's like, the moment for me is like, what are we doing? Like there's this like kind of, industry here. And yet like I still have to use these kind of more antiquated ways to do things like this. And so that was like the moment where I definitely really started digging deeper and deeper and kind of going into the rabbit hole again of like, okay, where are we? What needs to be done? Um, and yeah, so that's kind of the journey into eventually realizing like we were able to. So I have three other co-founders at Alpen, and uh, at the start it was like kind of broadly something in fintech felt like we needed to kind of improve there. Still didn't have the precise kind of thesis that we wanted, but I had some investors from the last company as well that wanted to back again. And so we were able to raise like a pre-seed at that time, quit our jobs and then go like really deeply uh, explore kind of the idea space here. And yeah, over, I would say maybe 4 to 6 months or so, We eventually landed on the thesis. So this is like late 2022, which is, what we're doing today, with a nearly 40-person team, with, fantastic partners and, approaching kind of mainnet. So it's been the journey.
Nice, yeah. Especially right now, it's very, very exciting time. And I think it's so interesting to hear that at that time when you first encountered Bitcoin, it was through a site that directs you to, as you say, esoteric parts of the web. And now there's an entire industry. You've been actively working on it for years, and
Yeah.
it's so fun to see it evolve over time. And I really do like how you mention about the importance of not just focusing on the technicals and the product side necessarily, but also with the process. So, and then also focusing on how people use it. So you mentioned about how with your first startup, you were learning about the culture of the organization, learning about trying to achieve product market fit, and even some of the design processes that you learned about rapidly prototyping, seeing how users will use it, and really focusing on that user experience. Yeah, I really liked how you mentioned that as well. And just a point that you briefly mentioned before about how the early vision in Bitcoin is still not fulfilled as of yet. I'm curious to hear about how you saw the Bitcoin space evolve over the years and what limitations and challenges are still present in it that led you to um, first found Alpen and also just currently working on those issues. So if there's any like key challenges that you saw that in the past that have been addressed now, but any kinds of new challenges that we're currently seeing, just curious to hear, since you said that the early vision in Bitcoin is not quite fulfilled yet, what you see as the end vision or the end game for what Bitcoin should look like.
Yeah, absolutely. I mean, even if we go back to, so there's like early vision, and I think you're gonna have to go to like Bitcoin forums and like kind of like like some, yeah, like what now seem like more esoteric parts of the web, right? And then there's, like I think maybe the second stage, like I remember 2013, 2014-ish, like there were, like Reid Hoffman dropped like a piece around kind of investing in Blockstream and like some of the visions there, and there were uh, really kind of really awesome ideas of like, okay, like, Bitcoin is going to be useful as like this kind of global freedom money, basically, right? Like you're going to be able to do all kinds of things. It's programmable. It's you should be able to like just send value, one person to another, etc. And I'd say like, okay, so like where Bitcoin's like really succeeded, and like obviously like we're building on Bitcoin, and our thesis is very much rooted in Bitcoin, and where it is um, it is the leading, money here. Like there's so much, so many kinds of all kinds of entities that have gravitated, individuals, entities, etc., that have gravitated to Bitcoin as money. And I think as the store of value kind of asset that is just, it's better to kind of save in Bitcoin. Um, it's certainly succeeded in that way, and I think it's going to continue to succeed. Like money ultimately is influenced a lot here by Lynn Alden, and like she has some fantastic books around this too. But it's this kind of like emergent social phenomenon more than it is like a technology. Um, it sort of like, it's a shared belief across society, um, and in the same way that this is true for gold or even kind of fiat, and whatnot. Like I think Bitcoin has certainly established itself as like this leading money, and I think it's going to continue to like consolidate over to Bitcoin. And the consolidation part is like if you look at monies, monies love monopoly, so to speak, right? Like they like there's a power law structure usually, and there's going to be consolidation. So I think there Bitcoin succeeded, but then you know in terms of like, okay, is it easy to use? Is it interoperable? Is it programmable? Is it private? These are like really parts of the early vision. Like Bitcoin should be freedom money, And freedom money in my definition is like this, like I should be able to send uh, very easily, uh, you know, value privately, and I should be able to do more with Bitcoin, right? Like, I mean, gold thesis is like, sure, it's like a great store of value, but like we can do so much better than gold. I mean, this is like a digital uh, kind of anyone with the internet should be able to access kind of money. And so why can't we use it as this like base collateral to get financing at the best rates possible? Like, why can't we tap into some of the innovations that have happened in parallel in DeFi, on-chain finance, with the best, you know, money that's available right in this industry and just on the internet. And so those things like, feel very like, felt very unsatisfying. Like I can kind of hold it, and like most people were just kind of taking it and holding it, and they weren't actually using or you could use it, but it was just so roundabout. Like you have to go kind of get MetaMask, and like you're worried about like maybe fat fingering like something and having your funds stolen. You have to kind of convert it over to some wrapped version and interact with it with like kind of this really clunky kind of user experience. And so that just led to like, I think, much more limited kind of adoption in terms of the utility. Um, yeah, so I would say that, and I think even the side chains, which were I think like the right kind of attempt at like, okay, can we like we know that Bitcoin as blockchain is more restricted. That's by design. Uh, but can we do more interesting things there? I think uh, the ultimately it didn't take off, and I think a large part of that is like like it was the product experience and the kind of like kind of go to market that some of these uh, chains ended up taking was just not enough, and in others it was just like kind of more unsustainable use of like new tokens, et cetera, where we saw like kind of big spikes and then kind of drop off after that. And Lightning certainly like adds this more faster capability, but even Lightning as an architecture still like had these limitations around like liquidity requirements for different channel kind of rebalancing to like the interactivity requirements that ultimately uh, like you could use it more as like a more sophisticated user in a non-custodial way, but if not, then ultimately it's just another centralized kind of use of Bitcoin. And so it felt like it addressed some elements of maybe moving and balancing Bitcoin fast between different larger entities, but to the end user, it was still like it felt like it was an unsatisfying kind of answer to making Bitcoin more useful.
Yeah, got it. And I really liked that part when you mentioned that you see Bitcoin as this emerging social phenomena rather than just a technology. Instead, it's a shared belief that's held with many members in society. And Bitcoin succeeded in the aspect, as you mentioned, in defying that uh, traditional power law structure that's involved in money, and that involves things like consolidation and centralization. But there are still some aspects that were part of the original Bitcoin vision that still need to be worked on today. You mentioned with interoperability, with privacy, programmability, and then even just the enabling greater accessibility. Anyone who has an internet connection should be able to use Bitcoin, and enabling this concept of freedom money. So I really liked the way that you put out your vision to what you see Bitcoin there, and also some of the motivations as to why you're working on Alpen now. You mentioned about some of the limitations that are involved with Lightning, for example, about those liquidity requirements and some characteristics that make it more centralized. But curious to hear about also the reasoning why Alpen uh, chose to build their own roll-up design on Bitcoin. Any kinds of specific challenges that or limitations, trade-offs that exist in other Bitcoin-based zk rollups, for example. Just curious to hear about what motivated Alpin to uh,
Sounds good. Yeah.
go on and yeah, have their own roll-up design. Hmm.
Yeah, I think so. One, we're the first company, as far as I'm aware, in this space that started actively building towards like a Bitcoin rollup. We landed on our thesis fairly early. Like basically, members of our team um, wrote some of the most original kind of early designs of Bitcoin rollup. So actually, as far as I am aware, the very first design specifically around Bitcoin zk rollup was by Trey Delbonis, who's on our team, who it's another esoteric part of the web. It's his like blog site where I think the title is Bitcoin zk rollups, and he kind of walks through all the different gadgets. Trey was previously working on Lightning at MIT DCI and other things, and so this was like I believe it's like 2022. Um, and he's been kind of updating the blog maybe up to 2023. Um, from there, John Light, who's a product manager on the Alpen team, worked on or released Bitcoin rollups.org. And this was like a really kind of extensive survey around opportunities, possibilities, et cetera, and the various kinds of rollups. And around that time as well, like the like myself and like three other co-founders, Avishkar, Pramod, and Chandan on our team, we had completed like another like 40, 50 page kind of paper around a very specific design of doing a Bitcoin zk rollup using Taproot, using various things, and where we design end to end basically the protocol. Except that was under some assumption of like being able to get one or two opcodes into Bitcoin. So like under that assumption, here's like a fully fleshed out kind of design of a end-to-end Bitcoin zk rollup. So I think in part it was like we were early into this space, and so we were already exploring a lot of the earliest kind of research designs that uh, uh, that we had like very kind of clear opinions around how this ought to be done. For us, like some of the biggest parts of this were um, the BTC collateral that's kind of available in the more programmable environment, and a programmable expressive layer two should not be it should be as trust minimized as possible, right? Currently today it's either completely controlled by a single entity, or like a kind of or like a majority of entities in this kind of like federated multisig. Um, and we didn't have a clear answer to that early on, and so a lot of the uh like after Robin Linus came up with BitVM, we had initially, when the paper just kind of initially came out, it was it felt like there was like a really cool direction, but there was maybe like five more research problems kind of missing here before it's like anywhere near ready. So we very initially dismissed it, and then only months after really kind of took another look. And even at that point, like this was like the early kind of first VM paper, it didn't seem practical, right? Like there was so much like being it maybe could help us build like more trust minimized kind of BTC bridges into the L2, but the functional requirements of that, like to be able to withdraw back in this kind of like optimistic uh, like challenge kind of paradigm was just impractical at the time. It was like 40 rounds of back and forth, each round being a week. I mean, 6 to 9 months just to like kind of resolve a challenge to do like, on a single withdrawal or something like that. And so there's a ton of innovation that has happened like maybe over the last year and a half, to the point today where it looks, completely different, uh, but we think it's now like very practical, and in fact, we've already completed one audit, and in another week or so, we're going to go through a second audit of these systems. So, like, really, have come kind of a far way. But you'd asked about like, why the design, right? So, for us, it was getting the BTC collateral to be trust minimized as we can, and I think about trust minimization not just as like okay, that's nice. Ultimately, like right now, it's like a one of n trust assumption on liveness safety to be able to exit BTC back from the layer two system back into Bitcoin. Um, I think about that not just like from, that's nice to have, obviously, like, you take less kind of trust assumptions and this is good for users. Uh, but also this is like more of a neutral, like, BTC standard for the industry, right? Like our alternatives are WBTC or CBBTC. One's controlled by BitGo, one's controlled by Coinbase. And, sure, like maybe some users are already trusting those entities and they're fine kind of bridging this way into the wrapped versions on Ethereum or other places. But, um, there's so much to the industry or the other exchanges, custodians, wallets, non-custodial, like custodial, all of these that, I just don't think they want to adopt like something that might be even as an adjacent competitor. You're basically giving BTC in control of a Coinbase or BitGo, which uh, have these more closed standard BTCs, right? And so I think of these as like neutral, open standard BTC, as well as like kind of trust minimized BTC. We thought that was going to be a really big part of it. Ultimately, we definitely want to see trustless, and like we're going to go in that direction, and that still will require some opcode changes. But we think where we are today, there's already a ton of demand to be able to bring this. And other choices were also important for us. So, for example, uh, we're designing our roll up in a very different way, I think, than a lot of other teams. So we haven't shared much on this. We will have like kind of a longer form content around this as we release kind of next versions. But we see like this issue of interoperability that exists in rollups to be like an important one that needs to get resolved. Like we have a bunch of years of what's worked and what hasn't worked within kind of rollups of that experience to kind of learn from. And so one of the things is that like if you look at Ethereum, you have all these kind of different rollups that are very siloed, like they're almost like different execution like environments that uh it's very hard to kind of interop between these things. It's very like the liquidity is quite fragmented, and this permeates all the way to the user level where like, I have a wallet and I'll see all these different versions of the same, stable coin or like the same like ETH or something like that with every single. So the UX fragmentation is also like a real problem there. And so we thought about, okay, how do we actually think about this and resolve this? So we have this roll-up architecture that decouples what we call the execution environment, execution layer, and the orchestration layer. So the idea is that, we're going to be deploying, Alpen, uh, which is an EVM compatible execution layer uh, in this kind of roll-up stack. But once we've decoupled this, which, this is going to be launching as a decoupled kind of thing, um, other execution environments can also launch uh, kind of uh, next to Alpine, and then you have like a really kind of thin, well-designed orchestration layer that we spent a bunch of time thinking about how do we prevent state growth, et cetera, in something like this. Basically, it's this nice abstraction that allows other types of execution layers to also deploy and be interoperable, in a much faster way, share liquidity, etc. But have ultimately different design choices. So someone else could do like a simplicity based execution layer, and make this interoperable with our Alpine EVM layer through this orchestration layer, which ultimately settles into Bitcoin. Because we wanted to like kind of hit some of these design choices as well, we spent it didn't make sense for us to like, let's say, just go with like OP Stack and kind of go that way, um, or reuse some kind of existing roll-up software.
Got it. Yeah, so the main kind of design considerations that the team was thinking about first, having the BTC collateral to be as trust minimized as possible, and then also with the rollups themselves, trying to address the issue with interoperability and UX fragmentation. Yeah, and it's really great to see that those considerations formed Alpen's current design using both the um, execution and orchestration layers, and I really like how flexible and how modular the design is as well. And then also wanted to hear more about the evolution of some of these design considerations or optimization efficiency techniques that Alpen has been using. So you mentioned that um, Trey has this kind of esoteric blog, and he was doing some early work within exploring ZK rollups on Bitcoin. And I know the Alpen team came out with a white paper a few years ago called ZK rollup on Bitcoin, one of the earliest white papers about that. And from there, you guys had some other design considerations, like for example, the Snark NATO
Mhm.
design, incorporating that to the roll up, and then looking at the VM, you guys were involved with the effort there, but now focusing more closely with Glock. So curious to hear, like within that path, were there any types of key learnings that the team had during those stages, and if it helped informed kind of the design considerations to incorporate over time. Just curious to hear about the evolution of the way that the team approached it.
Yeah, totally. I would say like, very early on, we were like, okay, you just need like, one or two opcodes here and you can build this like awesome, simple system. Relatively simple system, but like, you're suddenly introducing expressivity and via that, privacy and scalability into Bitcoin. Um, and like we thought, okay, like let's get these opcodes in. Surely we've shown this kind of like a design and kind of kind of argue for the utility of that kind of infrastructure for BTC and usage of BTC. And so uh, obviously, it took a lot longer, or it's taking a lot longer to get consensus in the community for kind of what kind of opcodes make sense here. Um, so the idea that like we could just kind of soft fork in something in a year or 2 years, et cetera, and then be able to like kind of do that original design did make sense. And so, I think we shifted more towards like, okay, but like let's get started building even with like honest majority kind of BTC. We thought we could just do a lot better on the execution environment side in terms of being able to bootstrap different kinds of markets there, like lending markets or exchanges, or kind of all the utility that we could kind of tack on that current side chains were not resolving, right? Um, like get distribution kind of integrations and yeah, like really kind of nail the UX and the access to like all these kinds of use cases and bootstrapping and go to market. And so that was kind of the initial, like I'd say still early kind of thinking of like, um, and that's the direction we started building towards that direction as well. That looked maybe more like a sovereign roll up, and the bridge we would still like our thinking was still like, you know, like we're not that far away, even if there's not like a soft fork on Bitcoin. It feels very natural that like you have like ZK as a primitive, uh, and that's the like right abstraction. If you can verify somehow, even optimistically, a proof, a ZK proof on Bitcoin, and that's the kind of missing ingredient to at least be able to upgrade the breach later on. And so this was like, yeah, we started building this already, and then BitVM paper had come out, which was a total roller coaster in terms of excitement. I mean, it was like a new direction and like a really cool idea. But then the roller coaster was like, but it's not something we could take to production at that stage. It was just not something that like it was quite complex. But even aside from that, the functional kind of requirements were just not like our requirements for what we'd consider kind of production ready, or like would be like weren't there. Basically, there was a lot of issues to kind of still be sorted out. And so it was like a cool direction nonetheless. And so uh, you know, our biggest pain point at that, like it was, how do you get like the challenge resolution window to be shorter? Like Bitcoin being able to adjudicate like, so someone makes a claim, someone challenges, and then they kind of do this back and forth. At that time, it was like, so like this uh, binary kind of approach of like getting to a specific part that was wrong, kind of like similar to fraud proofs on Ethereum. How do we get that time to be able to resolve in the worst case to be shorter? because that directly affects, how long does it take for a withdrawal withdrawal claim that is challenged to actually be settled on Bitcoin. And this is like being able to exit the system in a reasonable way was really important. So anyway, Snark NATO was birthed out of this idea that on top of like basically improving on BitVM, uh, we were able to, I think, get it down to 4 rounds or 5 rounds or something along those lines, from closer to 40 rounds, um, and like that felt good, like, but maybe still not good enough. Like there were still like a sort of other problems to resolve. So we're talking like, okay, a month or so to be able to resolve the challenge, and exit the system in the worst case. And then there's just still other kinds of problems, like that were like that was on the verifying like an arbitrary claim part, and then there was like kind of the breach protocol part of like some of the liquidity challenges that we saw, and some of the like kind of parameter choices being still kind of hard to get the right set of parameters. And so, uh, yeah, as we were working on Stark NATO, I think we were even getting some of these ideas down to like maybe from initially 4 rounds or so. Like we thought maybe 2 to 3 rounds work, but in any case, Robin came up with BitVM2, and that was like a really neat concept. I think it was like theoretically, it made a ton of sense, and it basically brought this whole thing down to like 1 to 2 rounds essentially. If we look at it in the context of the bridge, um, but if you would just look at it as a general primitive, as like a single kind of round way to make a claim, um, like assert a claim, and then be able to like kind of challenge and resolve slash a fraudulent claim. The only issue there was it wasn't, so the idea came, but it wasn't like immediately practical. He had this kind of idea of like, okay, well, let's just write a Groth16 or like a ZK proof verifier in Bitcoin script, and it's going to be really big. But we could like chunk this up into a bunch of different parts of the script, put it in this like taproot tree and this Merkle tree, and like basically, if the verifier is wrong, then then one of these leaves must be wrong, right? If then we could just spend one of the leaves. We don't need to spend this entire giant script, which Bitcoin wouldn't be able to fit anyway. So that was kind of the core idea, but the issue was that even writing the verifier on Bitcoin, it was just so big that like chunking this up and kind of doing this is still like kind of untractable at that time. And so there's a lot of effort by a lot of teams. So Alpen was very involved in this as well, and everything from the on-proving pairing paper, which simplified the verifier circuit for Groth16, that paper, to like actually the research engineering part of this, like actually implementing a lot of those ideas in, we were very involved with there. And so this was within the BitVM Alliance. Other teams were also kind of involved in various other parts of that design and implementing it. And so I'd say over maybe 6 months, 8 months, something like that, like it, like the overall verifier script became small enough that chunking this would work. But in any case, like it was just like kind of barely working, right? In the sense that like uh, if someone makes a claim through this BitVM2 protocol, about like, hey, I made a valid withdrawal or something. Let's say that's kind of the claim, that's relevant to us. Um, then let's say they lied about the claim or something, and so anyone could kind of challenge that, uh, and like they like basically they would have to assert their claim, but to like slash like a fraudulent operator to like actually disprove, it would take close to like an entire Bitcoin block of data that you need to put in Bitcoin. And so we obviously that's going to be very rare, like that happens in this kind of optimistic protocol, but it's really important, right? Like that someone should be able to like slash a fraudulent operator. And if that's like taking, an entire, like close to an entire Bitcoin block, and like that has a lot of implications in terms of like what the bond is that like everyone kind of needs to put up, the economic kind of incentives of this whole protocol. So it was still like something that like seemed good enough, and we were hardening it. We went through audits, etc. But it was like in the back of our mind over even the last year or so. we've been working on, there should be something better. And so this is the garbled circuit based approach, which is like, I think the ultimate kind of form of, it moves even the verifier complexity that BitVM2 had off chain out of Bitcoin. And you have like basically, like a fraud proof can be something as simple as like a single signature. Um, and so you have this like, same rounds as a BitVM2. So like it has that like, property that BitVM2 is really good at. Um, and the, like slashing someone that's fraudulent, is like there's like a 500 to 1000x kind of overall improvement in terms of on-chain data that you need to put, right? And so this has again like all these like downstream implications on bond size and just like how robust this is. And so this was Glock. This is what we've been calling Glock. I think others in the space have also been working on garbled circuit based approach. I think Jeremy Rubin put out like Del Bragg initially, and then I know that the Citrea team, the Babylon team, and Robin as well. Like, and they've been working on various ways of kind of utilizing garbled circuits to make this work. And ultimately, like that feels like the cleanest, most auditable way to do this. And so we made this decision of like, look, BitVM2, like we were in the midst of like even audits, etc. We could move forward with this, in our upcoming mainnet, but we like like we had already made some progress on implementation as well here. We felt like we can go even better without actually extending the timeline for mainnet with a much simpler kind of primitive with Glock, a lot less complexity, a lot less uh, cost to operate these bridges. Um, and we would feel better about the overall kind of security of that system. Um, and so like that was our transition. And so you could definitely see over the like last 12, 18 months or so, it's been so much about evolving the BTC bridge, which ultimately rests on how do you kind of verify arbitrary compute on Bitcoin in the most like cleanest, most efficient way.
Yeah, got it. And yeah, I really like how you mentioned that the team was looking at some of the current approaches, solutions out there, and saw that some areas may not be immediately practical with functional requirements not being production ready as of yet. So that led to you guys, for example, reducing the number of rounds in Snarknado, and then also addressing the amount of on-chain data and reducing the verifier script with Glock as well. So really great to see how the team progressed over time with that. And I also wanted to, just in regards to Glock, also curious to hear about some of the specific characteristics or features that is unique to the to Glock's approach that enables for any kind of special advantages or benefits in terms of, say, improving efficiency, for example, or improving or optimizing on some of the other garbled circuit based approaches. I'm aware that, for example, you guys use some different signatures and also use the idea of a designated verifier snark as well. And all of that combined really helps to reduce the um, garbled circuit size. So wanted to hear more about how what makes Glock's approach unique.
Yeah. I mean, I think Glock, we think about as like an umbrella term, not specific to like the DB designated verifier approach or anything. I mean, that's as it was introduced in the paper, it's like the class of like, these optimistic protocols for verifying arbitrary compute use little garbled circuits, right? And there's basically, you could approach that with like using a particular type of Stark, which, like I think Glock 25, as it's called in the paper, is like a particular instantiation of using this DV designated verifier Perry snark, which actually it's not even so. There's like a fun kind of fact in that paper. The as far as I'm aware, Pari was like the smallest snark in terms of like the proof size verifier complexity. Uh, that was known up to that, yeah, like it was, yeah, smaller than Groth 16 essentially. So there's some improvements even on Perry that was made, like Sotim Egan, who wrote the paper, made. So it's even a smaller version of Perry. So as far as I'm aware, it's the smallest snark that is known in that paper. So it's kind of hidden in there. The designated verifier piece and like kind of moving in that direction was we needed to essentially, like, the construction is uh, using this garbled circuit evaluation off chain. So the idea is that, like, you can, someone that wants to like make a claim about validity of some kind of computation, which amounts to the validity of a snark, as we know, like that's the abstraction. Um, does so by like signing the inputs on Bitcoins. And off chain, like these watchtowers would have, or operators would have, a garbled circuit that they can kind of use. Okay, so they can use the inputs that were signed on chain. They can evaluate that garbled circuit, which the circuit itself basically is like verifying the proof and leaking a secret if that proof is actually false. Um, and so if the proof is true, it would never leak the secret. And so, well, hence the like kind of use of garbled circuits in the first place. Like, it doesn't reveal that secret that is there. So um, turning a Groth, like, see, initially it's like, okay, you have to take this like snark verifier circuit and turn it into this like garbling like table, basically, to like kind of have this garbling and evaluation be done using that circuit. It turns out, like, when we did the numbers, and so we looked at this over a year ago, and it was just way too big. Like, the garbling table would be so huge that, like, kind of even storing this offline with the watchtowers, etc. We were talking like tens to hundreds of terabytes or something like that, um, a footprint, and didn't really seem feasible. And so the push was like, okay, can we simplify, like, use all these kinds of tricks, coming from the garbling uh, circuit literature, like mostly, and like there's like a bunch of cryptographers, like garbled circuits are not kind of new cryptographic primitives by any means. Multi-party computation research, there's so much use of this, and there's like a lot of research around simplifying and different types of circuits, and kind of simplifying the gates and so on. But we were also approaching it from the ZK side of like, okay, how do you get like the verifier circuit to be even smaller, so that you have even smaller garbling tables, and that led to kind of, like, okay, well, we're already assuming one of n assumption when we do, the challenges, and, under this paradigm, we're restricted by one of n anyway, because Bitcoin doesn't have covenants. We have to do this kind of emulation thing. And so designated verifier fits well within that paradigm. It's like, it's basically, it's, uh, it, you have a specific entity that can kind of verify your claim. And because we have, we could do that pairwise with all the operators. And so it didn't need to be the case that anyone can kind of verify your claim if you have like a permission kind of one of n set of operators or watchtowers here. So DV allows us to kind of reduce this further in terms of the size. And then kind of the extension of Perry with its DV snark approach just made it small enough that it was like concretely, immediately feasible, like in the, like, really like tens of megabytes, from the kind of, terabyte numbers that we were seeing. Um, and so that was kind of the approach. What's interesting is, like, Groth, like, I mean, due to like kind of like a bunch of DAO teams working on this and kind of improving this, there's been some really great progress that's been made using Groth as a Stark as well. So, like, the advantages there is like it's just, Groth is like common, it's more battle tested, hardened, etc. And at the moment, like, I think the numbers for doing this using Groth, like as of like 2 weeks ago or something like that, are actually really, really practical. And so, like, we're exploring that as well. And we see Glock as this like full umbrella of kind of can use any kind of snark here to to do this optimistic construction. Yeah.
Yeah, got it. Really like as well how flexible Glock is, especially with being able to, as you say, like adapt to potentially different kinds of snarks. And really cool to see all of how all of those design considerations come together and really help to improve the efficiency and optimization of these current techniques. And then also, I wanted to ask you more about the user experience with Alpine. I know that you very heavily prioritize on the functionality, the usability, even before your time in Alpine in your first startup. That was a big priority that you had. So curious to hear how Alpine shapes the user and developer experience, and then also any types of new use cases that these developers can build or users can engage with on Alpine that previously weren't possible.
Yeah. I think that, you know, the first part of this is like typically when we see new L1s or L2s kind of in the space emerge, I feel like there's this kind of repeated playbook of, okay, like, we need to go, like, there's like kind of the, what do we have for, like basically how many applications are in our ecosystem? And it's like this kind of metrics driven, kind of repeated playbook of um, like let's find kind of, spin up new forks and new teams, and then kind of like try to get as many things as possible, like, and have this like ecosystem be, full of everything. And I think for us, like our go-to-market approach kind of reflects this user empathy piece a little bit more, which is like we're just like really obsessed with what are like we talked with a bunch of different people in the Bitcoin space, the Bitcoin holders, et cetera, et cetera. Um, and we just we're looking at like what's in demand, like what do people actually really want that they're not being able to get right now. And can we do those things really, really, really well as like setting up the foundations for this ecosystem? And thereafter, it's expressive, it's permissionless, and people will build and can build anything else, beyond that. And we would certainly encourage it and want that. So for us, it's a lot around, focus is a lot around Bitcoin finance, like a DeFi. And even within that, like there are some kind of like lower hanging fruits, especially around how does Bitcoin and stablecoin kind of interop. Like, people, like we talked with different wallets. We went kind of like the different, places people kind of are, whether it's a non-custodial wallet, it's like one of the top, Bitcoin wallets to, uh, like a custodian to another exchange to kind of, basically places where people have Bitcoin, and kind of looked at their pain points and kind of how users were using it. So like it's an example, like one wallet was like, hey, people come in, they unramp, they buy Bitcoin, and then, they'll transfer, hold it, et cetera. That would be maybe the common use cases. But after that, they want to swap it with stables. And when they do that, like now they have like a stable coin on like Polygon, and they realize like to do anything with that, you need now like the Matic token or something, like, or, and it's just the experience is so kind of bizarre. And, because like, okay, well, then now you got to go get Matic token somehow. Um, and so like, this, like, it makes much more sense to kind of verticalize this way. Right. And so, uh, given that users want to interop their Bitcoin with stablecoin, whether it's to like borrow against Bitcoin and get stables, or whether it's to kind of, swap between, um, like that experience should happen in an easy way. And in particular, like different kinds of distribution partners should be able to like create the kind of user flow that they want without having to deal with like this whole like kind of going to another thing and needing another guest token and so on. And so we think that like, in one case, like I just mentioned borrowing, like that's like a really big area that like a lot of Bitcoiners like don't want to sell their Bitcoin, but they want to get access to uh like stables, or dollars, against the Bitcoin that they have. They want like spending power as a utility for their Bitcoin, and dollars are just like a lot more compatible everywhere, today, right? And so we know for sure on chain, like the rates are so much better than off chain. And like like right now, there are a lot of Bitcoiners going off chain into custodial kind of solutions. I mean, like even we saw that with like BlockFi, we saw that with, um, other kind of, uh, services that emerged. Ultimately, they failed and people lost a lot of money that way as well. But they were custodial, like, so they were giving up their Bitcoin to some of these custodians, and they were getting, like a line of credit, dollars, et cetera, against that. Um, and so, like, the reason they were doing that is it's that's just so much easier than kind of going to give, like, as a Bitcoiner, like going and using what like MetaMask and engaging with Aave on their web app and doing all of this. Like, it's just not like a common kind of paradigm to interact with smart contracts, and like you're just worried that you'll, even though the rates are so much better there, right? Um, and so, like for us, we've been spending a lot of time in that, as well, of like, okay, how do we get this to be as easy as possible, which means meet users kind of where they are. So like go partner with a lot of distribution, uh, like players here, uh, and be able to like, integrate like these kinds of Bitcoin finance things directly on those platforms in a way that users don't have to think about, like kind of moving to, a wallet and then interacting with a web app, et cetera. It's like they have an intent. They want to, let's say borrow against Bitcoin. They should just be able to do that with a few clicks. Um, so that's like certainly like that's an area. I think the other things would be like, account abstraction, primitives that allow for like, we just want to wow people, especially within Bitcoin, that you can do payments in such a simpler way. With actually programmability kind of helps here. Like you should be able to do like a, if you want to, like even like a Face ID based like payment to someone else, like like something intuitive that you might be already familiar with your iPhone, and and do so without like fat fingering anything, and so on. So, uh, like there are areas like that we're just hyper specialized in, and I think, other bets that I'm just like really excited about as well, be like Bitcoin backed, stables. I think that's like a really interesting category of like, I mean, we announced the Bitcoin dollar, uh, of having, stables that are purely based, backed by over collateralized, CDP style kind of, but just Bitcoin, allows for its use in more private kind of based, privacy based applications where it's just much harder to get, the kind of centralized stable coin, into those, just due to like regulatory kinds of reasons. So you have this like uncensorable dollar, which is like, you know, backed by Bitcoin. And in fact, the more use and distribution we get on that dollar, it's also like a two-part thing, because then it makes it easier and cheaper to borrow dollars against Bitcoin as well. So like with the Bitcoin dollar protocol, it's sort of, there's like a cool dynamic between more distribution of the dollars reduces the rate to borrow against Bitcoin. And, we think that that's going to be like an interesting play as well, uh, for getting, I'd say like, part of how I see UX is also privacy. Like a lot of their users that we've talked to, they actually see privacy as like a part of the user experience that's important to them. Um, they see, the properties of like uncensorable kind of, but also the stability of the dollar as part of that. And so this actually, I see even within satisfying that UX, paradigm, rather than like a cool science fair project type thing. Um, because we know that like, I mean, the current state of privacy on blockchains is abysmal. It's like it's wild to like see all of the kind of players, in traditional finance or traditional even kind of, like tech companies coming in and saying like, okay, like we want to do payments through stables now, on chain. It's like, well, like it's like everything is transparent. So like if Walmart's going to try to do some payments, kind of through that, like will some of their supply chain be like leaked, or like some kind of like people will start clustering and kind of getting usage patterns and so on. So privacy is certainly, I think, a big part of user experience. And so I just wanted to call that out as well. And how we're thinking about the Bitcoin dollar project.
Mhm. Yeah, absolutely. Very, very exciting how many different aspects you're thinking about, whether it be with privacy or just with the general user experience. With the status quo right now, users have to jump through many hoops to say just interop Bitcoin with staples. But the Alpen team is working on a more streamlined, more user intent based, just a few clicks kind of version to allow these users to achieve these actions in a much more straightforward way. So that all sounds great. And just as a last question, um, curious to hear if you have any kinds of announcements that you'd like to make, or for any kind of BTC holders in the audience, any kind of devs in the audience, what are next steps for them to get involved with Alpin?
I think there are a bunch of announcements that are coming up. I think like we're signing with like a lot of different partners, even collaborators. We're really excited about that. We're currently on a public test net, so go kind of build there. And yeah, reach out to us, join our Discord, Telegrams. Uh, like for us, yeah, like I think over the coming month or two, you'll probably see a bunch of these partnership announcements that I can't share now, but I'd say our core focus right now is getting towards like a hardened thing as we go and launch mainnet. If we're recruiting also like if you want to be part of this, I think there's something really special about the Alpen team. I think that's the best part about the Alpen team. We have folks from all over the world, but also all over kind of different backgrounds, and even folks that previously worked on kind of different kinds of chains, et cetera, that want to kind of they want to build all these the utility against the hardest money, and it's a really fun time. And so I would say like we're actively hiring. Thanks, Alice, for letting me uh, get a chance to chat about this. But we're also looking for devs. Like I want to build cool things. So like I talked about like a focused approach to go to market, but at the same time, like our testnet's open and it's permissionless. And like if you have ideas, like come and build, and like we'll support. We may even be able to fund you guys. Like if it falls within like our initial go to market. And so really, yeah, that's what I would say.
Yeah, great. And thank you so much, Sims, for coming on and sharing your origin story with Bitcoin, what you see as a vision behind Bitcoin, as well as this social phenomenon, not just a technology, and all of the design considerations that the Alpine team made over the years, how they evolved, how you guys shaped the user experience, the use cases you're all working on right now. So, all very insightful. And thank you so much again for coming on.
Thanks, Alice. Yeah, I appreciate it. It was a fun podcast.
Yeah, thank you.